Okay, so first thing I'm going to do is go over the lesson for today. So we are graphing ellipses. All right, so what we're going to start with is notice that A and B, these can switch out as long as A is greater than B. Okay, and these are perfect squares, so they have to be positive. And so that's one thing you need to know, and you need to know that 2A is your major axis, 2B is your minor axis. All right, so even though this is like an initial page and it's giving me the standard form right here of an ellipse, this may seem like a kind of fun page and you get to ignore it, but I actually put some important information right here, so make sure you don't forget it. All right, so on the warm-up, I'm actually going to skip the warm-up just because lack of time. All right, and what I'm going to go to is what are the let's talk about the parts of an ellipse. So notice right here, this axis is longer, so this is the major axis, and that's my shortcut for writing out major, okay? And this one is minor axis. And it does mean that whole length all the way across. And minor axis, I'll just do in red, it's this whole length across, okay? So that's your minor axis, and let's make that an S. All right, now the center is located right here, and that's C for center. There is another C in here, that's a length. The center is not a length. The foci are always going to be somewhere out here on the major axis, and that will be a distance of C, and we'll talk about that. So that's a foci, this is a foci. Focus, they're each a focus, you have two foci. All right, so the vertices, co-vertices, this is a vertex here, this is a vertex here, this is a co-vertex, this is a co-vertex. All right, on this one it's a little bit different. I'm just going to pick up another color so you can see it. I still have the center here, but these, instead of being vertices, are now co-vertices. All right, and this is the vertex, and this is a vertex, and the focus is going to end up somewhere in here. Okay, and this distance will be your C. All right, so an ellipse is the set of all points in a plane such that the sum of the distance of the points to the two foci is constant. So if I choose a point, let's say I choose this point, if I take that one and this one, because these are equal, these two are actually congruent. But if I could have this length and this length, they would be the exact same thing added together as if I chose a point here. Let's just change color. I'll go to black. This length and that length. So if I could add 1, 2, 3, if I could add the 2 and the 3 together, 1, 2, 3, those lines, it would equal the 1 and the 1 mark. Okay, it would equal those together. So if I add the pink lines and get an answer, add the black lines and get an answer, they would be equivalent. That's what it comes out to. The distance of the pink lines and the distance of the black lines would be equal. That's what this is saying. All right, moving on. Okay, whoops, I almost skipped a page. All right, so on this one, notice I repeated my equation, and notice the difference in the equation of that of a circle. So you have divided by a squared, b squared. A is always going to be your major axis, so this can switch out. So we have to look at this and determine what it's going to be. And the foci, here's the formula for the foci. This is very important. All right? So first thing you're going to do is I look at these and I go 25 is bigger, so this is my A, and A is 5 because I take the square root. This is the B, and it's going to be 3. I know the center of this circle is going to be at 0, 0, so I'm going to graph 0, 0, and notice the x went with 3. So 1, 2, 3, 1, 2, 3, and the y is 5, 1, 2, 3, 4, 5. The y is on top, that's why I'm saying the y is 5, okay? 1, 2, 3, 4, 5. And we would consider this a vertical orientation because it's longer vertically than it is wide horizontally. Okay? That also means that if I want to find the foci, I use c squared equals a squared minus b squared. Well, I have my a and b right here. Actually, when I square them, it's back to the numbers. So I have c squared, a squared was 25, b squared was 9. That's a total of 16. C squared equals 16. So I take the square root of each side, and C is equal to plus and minus 4 from the center. So I'm going to change my foci so you can see them. I go over 4, over 4. I just totally went in the wrong direction. Did I seriously do that? Up 4, 1, 2, 3, 4. I only went out 3 anyway, and 4. So this distance is 4 and 4, that's your C, and they are the foci. These foci are decent to see because they're at least a whole unit from the end. And so since I messed up, I'm going to wipe those out. Watch this on live camera. I can't stand to look at those. That will drive me crazy. All right, they're in the wrong place. You have to get rid of them. I can't erase with these pens. All right, so looking at this one, it's going to look the same, except this time this is your A and this is your B. So the A is a 5 and the B is a 3, which matches over here. But notice that the A went with the X. So in the X value, 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 1, 2, 3, and we would make the ellipse. Okay? All right. Now, for the same reason, your C square equal A square minus B square, since the A and the B are the same, it's going to give you the same answer. C is plus or minus 4. And in this one, it is going in an X direction. So here's your foci. They go out 1, 2, 3, 4. 1, 2, 3, 4, and we're done. Those are your foci. All right, and if you wanted to label these points for the vertices and co-vertices, you could list those. All right, so these are your vertices, your co-vertices. All right, notice how they are. They're opposite of each other. Now let's look at the utri, because these came up a little different. All right, and these we have 4 and 9, 16 and 4. So you go your biggest one, this is going to be your A, this is going to be your B. This is going to be the A, this is going to be the B. Now that's A squared, so you take the square root, you get 3, you take the square root, you get 2. A should be bigger than B every time. A is 4, B is 2. Look at that. So centers. And this was a typo. This should say center and center. All right, and the center is going to be 2, -1. Remember, they changed signs. And the vertices, what I will do, if I know the vertices, they come from the A, I will add them in a Y direction. So when I have this 2, -1, if you see me write this plus or minus 3, because that's the A value under the Y, this is plus or minus 2, the B value under the X. So what I will do for the vertices, the biggest one is the one that gets to add and subtract. So I'm going to leave the 2 alone. I'm going to have -3 minus 3 is -4. And I'm going to have 2, comma. Now, +3 minus 1 is 2. And then you can check it out. Notice that it happens. You can follow it. So 1, 2, -1. And you can say, well, I know in the Y direction I go 1, 2, 3, and I can get my point. 1, 2, 3, and I can get my point. It totally made the vertices here. The co-vertices are going to be out 2, 1, 2. 1, 2, and I can actually see them, and I can create this lovely red, white, and blue ellipse. All right, so the major axis length, let's talk about that. It was 3 on the top, 3 on the bottom, so a total of 6. Or it doubles the A, 2A, which is equal to 2 times 3, which is equal to 6. Covertices, where are they located? Well, I just did them. They're 2 away, 2 away. So if I take negative 2 plus 2, I get 0. So that's my x part, and the y stays the same as the original. Okay? And then add 2, I get 4, negative 1. My minor axis length, is 2 here, 2 here, total of 4. It became 2 times b, which is 2 times 2, which is 4. Now the foci, I have to do a little work for the foci. I'm going to do c squared equals a squared minus b squared. Well, in the original problem, I have what they were squared. So it's just 9 minus 4, which is a total of 5. So c equals the square root of 5. Now when I get a number like the square root, I'm actually going to count my lucky stars, because all I have to do is say, you go the square root of 5 out, which is just a little over 2. So here's 2. It's 2 point something-ish, okay? So it's somewhere over 2, and it's always on the major axis. So here's my major axis, and the points are there, all right? So the way I'm going to show it, this is what I like about it, because it changed the y direction. So my x stayed the same as my center, and the y direction is going to be negative 1 plus square root of 3, and 2 comma negative 1 minus the square root of 3. I am okay if you combine these two and say, oh, this is the same as both of these, 2 comma negative 1 plus or minus square root of 3. That means you make 2 separate equations. I am good either way, whichever way you want to write those. Okay? All right, I'm going to leave the second one. I'm just trying to make this video not as long as it can be, and I'm going to go ahead and do one out of each of the other 2. All right, so on this one, I am given, that's an example one that I've already done. Sorry, I have one that I'm not supposed to have. Let me find my paper. Sad face. Here's the front and back of that. Oh, I need the little half sheet. Hold on. Where's my paper? Panic. I'm going to have to go back over and get it. Oh, here it is. The corner of my desk. Sorry. I had to find it. All right, so these are the last ones. Oh, I skipped from number 2. I skipped from number 2 to number 5 and 6, so I am missing one of your pages. Shoot. All right. I'm looking for it in my notes because I've got lots and lots of notes here, and I'm not seeing the final. I think those are the ones I left on the copy machine. Yay me. All right, so let me go get them real quick. Sorry, guys, it's too long. Okay, got it. Sorry, I had to run across my room to get it. Look, it's just like you're here with me. All right. Sorry, ran across my room to get it. Number 3, this is the one I wanted. Okay, so on this one, you're given the graph, so you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and count back 1, 2, 3, 4, 5. Half of that, and my alarm's going off because I got to cover another teacher. And it's somewhere. There it is. All right. So I got a few more minutes. I can get this done. So in this one, there's the center, and I can tell I've got 2 on each side. So this is 5 up, 2 across. So I know that the center is located at 1, 2, 3, 4, 5, 1, 2, 3. Negative 5, 3. The major axis is going to go at, that's going to be my A value. I'm going to use the A, which is 5, and that's going to become, oh, my major axis is a total of 10, and so A is 5. That's what I needed. Not B, but A. All right? So the minor axis is a total of 4, because it's 4 across, which is the B value, and it's 2. So now that I know what the A and the B are, and be careful, I will make a mental note or actually write it over here to the side. The 5 went in the Y direction, the B or the 2 went in the X direction. It just helps me connect it. So when I do an equation, I'm going to have something squared plus something squared equals 1. And then I got to figure out what goes in the bottom. All right, so this is easy because I have negative 5, X, it becomes plus 5, Y, minus 3, because they change signs going in, all over. Now, don't think that A is the first one, B is the next one. It was B that was first. So it's 2 squared, which is 4. And this is going to be 25, which is 5 squared. And I'm done. The end. Voila. Okay? So it didn't ask me about the foci, so I don't have to state them. All right, looking at this one, I kept this at the top because when I do them in class, it's kind of nice to refer back to my equation. So that's all that is. Now what you can do is you can go 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. All right, this is here just to help you out. This is your center. Your vertex is at 9, negative 7. Well, I'm already at 3, 4, 5, 6, 7, 8, 9. This is a vertex. And this was, look how far away, it was 6 away. All right, so that distance is 6, that's the center. That means, even though it only gives me 1, that means there is another one that's 6 on this side. 1, 2, 3, 4, 5, 6. So here's my other vertex. And the covertex is at 3, negative 5. So 1, 2, 3, 4, 5. This is the covertex. So 2 down would be the other covertex if you need it. All right. Then if you want to draw it, you can. You don't have to. Okay. So there's your ellipse. And you go, is it vertical or horizontal? It is definitely horizontal. And the A will be this side, and the B will be that side, either top or bottom. It doesn't matter which side you go. This is also A, and this is also B. All right? So A, the length of A is, what did we say, 6? 1, 2, 3, 4, 5, 6. Yes. This is a total of 6. B is a total of 2. I'm going to write an equation. That's all you have to do. So we're going to use the center. Be careful. Don't use your vertex, okay? Those are on the ellipse itself. You want the center. Okay, so we have x minus 3 squared plus y minus a negative 7 makes a plus 7 squared equals 1. And then we have to figure out what goes underneath them. Well, in a y direction, we had 2. So A was my x direction. This was my y direction. So this is the 4, and that's 36. So I had to take 2 squared, and I had to take 6 squared. Just so you know where those are coming from. And if you need to take an extra step to write them down, you can. That's that example. One more example so I don't have to go running around. These are the hardest ones, okay? By all means, this is your challenge, all right? So the center is at 2, 1, 2, 1, 2, 3. And notice this says plus the square root of 5. That's the focus. And a vertex is at 2. So 2, 0. Out 2, up 0. This is a vertex. This is the center. So if that's a vertex, not a covertex, this has to be the A. Not only that, this is negative 3 plus the square root of 5, which is 2.2-ish, okay, in that ballpark. So you go up 2 and a smidgen more, it's right here. That is a focus. All right, that means that we would mirror this other side if you wanted to, and we're going to have something along these lines. It's just kind of nice to know what you're working with. So we know A is 3. A is 3. And we know that our C is the square root of 5 because these values did not change. When those values don't change, that means what's added, I'm sorry, these didn't change. This changed by the square root of 5. So this is your C. So if I have C squared equals A squared minus B squared, I get square root of 5 squared equals A squared, which is 3, 6 squared minus B squared. So I would get that as 5 equals 36 minus B squared. Why did I do 6 squared? I just doubled it. 3 squared. I don't know why I did 6. So 3 squared is 9. I was like, that is way too big. That's a 9. My bad. All right, so I'm going to subtract 9 from both sides. I get negative 4 equals negative B squared. Well, guess what? I can multiply by negative 1 or divide by negative 1. It makes both of those positive. Now I can take the square root, and I get B is equal to 2. So that means B would have gone out 2, back 2. I drew this thing exactly like it should be. I didn't mean to do that. It just happened. Okay, so my A is the X. So A is equal to 3. This is your Y value. And B is my X value. So I'm going to write my equation from the center. I get X minus 2 squared plus Y plus 3 squared all over equals 1. B is 2, and we said that was the X, so it goes to 4. A was 3, so that goes to 9. That's 3 squared. I'm glad I can square a 3 now. And that's a 2 squared, which is 4. So final answer. All right? So I hope that helps. I know this ended up longer than I meant for it to because I misplaced my papers. I'm sorry. Have a good day.